dimensions. As we have already studied a motion in one dimension, when we classify motion in two dimensions, we can classify it into two. But before that, we can quickly say motion in two directions is just motion in a plane. So the motion of a particle or molecule or anything that is moving in a plane is called a 2D motion. When we say 2D motion or two-dimension motion, what we mean is that motion that can be represented in a plane, that is your XY plane. Now in our syllabus, we are going to be looking into motion in 2D in terms of analysis of 2D based questions, and also the other type of question we call the projectile based question. So in this slide, I am going to do the introduction to 2D based questions, and as well as understanding the two-dimensional type of motion. So projectile based is also going to be the second type of motion we are going to talk about. Now, to carefully analyze the motion in two dimensions, let us quickly look into the diagram and analyze it carefully. Now, let us say we have a body that is moving in two-dimensional system as shown. The body moving in two-dimensional system as shown. If the motion of the body is moving and is following this path, we can call the path of motion a trajectory path, not drawn to scale. Diagram is just drawn so that the motion of the body in the what we call the positive x-axis, everybody should know that, and the y-axis. So we can classify the motion of the body at a particular point in time can be in two ways. Let's classify this point and call this point P. At that point P, we can infer or conclude that the motion of the body here is having two parameters. One across the x-axis and the other, you can see the x value, and the other and the y value. Now I'm not drawn to scale. So here we say the motion of body along x and y axis, that is inside a plane, is called motion in two dimensions. So if particle is moving, particle P that we have different values of motion along the x and along the y axis. So now if this body is moving with a velocity which is going to be tangential to the path of the motion, in this case we can quickly analyze the tangent move of a velocity and classify velocity movement of the particle P. At this point now, let's say the velocity of the body is moving, velocity of the body is moving tangentially to this. We have that. Like I said, diagram not done to scale. Just trying to bring out the best of diagram that we can see. Now, the tangential or the movement of bodies is tangential. We can say the velocity of body is moving in that direction. Velocity I call the vector of quantity, we say v vector. Now, we can classify the motion of this body into two planes now. The velocity is moving, which is tangential to the body, the direction of P, according to the trajectory. I said this is trajectory. We are still going to discuss a lot about trajectory motion later. Now, the equation of trajectory here, because we are drawing in a plane, we can represent by y is equals to f of x. What am I trying to say? At different instants of time, we can have two values of velocity. One is moving towards the x direction, we can say vx, velocity along the x direction, and the other one moving here, we can call vy, velocity. So you can see that the representation of two bodies or two motion of a body that is moving in both x-axis and as well as in y-axis is called motion in two dimensions. Now, we can resolve this motion into plane. Now, you need to understand something that if the body here is moving with a velocity, let's say with an angle, or the velocity is moving an angle of theta, we can actually try to bring out value. I'm extending this from my early classes. We might have studied all this. Now, if we say the angle of the body is moving here, let me just make it bigger for understanding sake and cancel that. Now, resolving this y component from what we have already discussed, now you can see that the velocity is moving along this. We have this is opposite, is the y-axis over hypotenuse. You say the velocity along the y-axis is taken to be vy sine theta. And if we resolve along the horizontal, which is the vx here in this point, you can see the one going at this point is your vy direction for understanding sake, and we are classifying the angle. Now we can say at this point, that is adjacent over hypotenuse, we set the body here, we move the velocity of vx cos theta. So now representing this, we can now say the net velocity of the body, which we call the velocity of the body we represent in vector form, because velocity is vector. We can say the net velocity of the body in 2D plane is equals to Vx I cap, you can see, plus Vy j cap. So this is the way we analyze and represent velocity of a body that is moving along 2 dimensions. So, and if you want to write it in terms of magnitude, you can write it as velocity, magnitude of speed, which is velocity, will now be equals to under root of Vx square plus Vy square. All these parameters and formula are important and are going to be used directly to solve questions later on in the syllabus when we continue. This is the vector representation of the body, which we are still going to discuss later on in the syllabus. As I said, this is just introductory part, and this is magnitude of the velocity. So now we can also calculate direction, which is the angle, and you have learned from early classes that it will be tan theta, just like the way we have classified motion in 1 dimension, that is rectilinear motion. We say tan theta from here will be equals, you can see opposite is Vy over Vx, and if we make our theta sub formula, it will be tan inverse of you have a Vy by Vx. So this is the way we analyze and solve for magnitude and direction of a 2D motion. So students should keep that in mind, that when we talk about 2-dimensional motion, what we need to keep in mind is what the motion in the plane, which can be in both x-axis and in y-axis. You can also consider another point on the plane, like the movement of this trajectory part. Now, if you consider another point, you can carefully look into another point. You are going to see, look at this point now, for example, we can take this point. You are still going to have the same thing. The value is changing with respect to time. At one particular point in time, the value of this velocity is changing in both x-axis and y-axis, and that is why we call it 2D type of motion. So to carefully understand this, we can keep in some note. We can write note. You can just keep in this note in mind that a 2-dimensional motion, a 2D motion can be analyzed. A 2D motion can be analyzed by splitting. I think that is better. That word is better. By splitting into two perpendicular 1-dimensional motion. 1-dimensional motion with time as constant. So what we are trying to say is that if we want to go by derivation, which is so important because of our JUPEP student, you can always keep it in mind from here. That is, I said here we said y is a function of x. Now, how do we come about y a function of x? We have discussed in our motion on a straight line, rectilinear motion, that is 1D based question, that velocity is a vector quantity, is given as dx by dt. I hope students still remember this. Changing what displacement by time, and if we go by that, and the same thing is happening both in the y component and in the x component. So what we are trying to say now is that as the time is constant, we can relate directly the value of the velocity of x. If we say this is the for x component, so for y direction you can also write the same formula, that is dx by dt. It will be dxx by dt and dxy by dt. So if you go by that, so far time is constant, you can relate what vs equals to dx and vy equals to what dy. So if you go by that, that means you can relate the y as a function of x, and that is how we come about the equation of the trajectory. So about that, we can talk about general equation of the trajectory when we move on later part in our under the projectile based question. We are going to talk about general equation of trajectory, and we are going to derive some important value in terms of vector analysis and other things. So we can also note another point now, which I think is also important for students not to make mistake. We can say that in the analysis, let's just make it simple. In the analysis, in analyzing, let me just use that, in analyzing a 2D motion, comma, 1D, that is motion in 1D, can be applied. So what am I trying to say here? We are studied carefully one-dimensional motion, and we know formula for speed, velocity, displacement, acceleration, and so on and so forth. So what we do in 2D motion is just we combine two 1D I mean one dimension, I hope students are following, two 1D based formula together to get a 2D type. So to carefully understand very well, let us take an illustration and understand carefully. What I'm trying to say is that from our examples we've studied in 1D, we are told that velocity of a body, let's say we have a body, velocity of a body is always given as from here, you have a dx by dt. Already studied. Acceleration of a body is a vector quantity, is given by dv by dt. So these parameters, which we can also write as remember, we've done all this in v dv by dx. So these parameters we use in one-dimensional motion can also be used in 2D motion. I'm going to take an example for us to understand the analysis better, and let us carefully look into it. Now for the example, we have examples. Now we have let's take out one. We have a particle moves in a 2D motion. Let's just put it like that, such that its positions depends on time, as shown. Such that its position depends on time as shown. So we have the position. The equation was given to be x equals to 4t squared plus 2t plus 3. First stop. The question is find the velocities. You can see velocities at t equals to 2 seconds. So we have two equations. This is the first one. The second one was y is equals to 5t plus 7. So these were the questions that we have before us that we are going to solve. And solving this question, we have to carefully analyze what we have already studied in the introduction. And as we move on later in the syllabus, we are going to discuss extensively on those important things. Now, when you see this type of question, you don't need to be panicked because you've already learned in instantaneous velocity on 1D. So you are going to use the same application to actually solve for this. Now, having said that, particle is moving in a 2D motion. That means it's going to have plane. It's going to have x and y plane, and you can see from the illustration given here, we are given the x values of the particle moving around the body and the y as well, and it depends on time. You can see that it's changing with respect to time. Like what we have here. Initially, we have the particle, and finally, it's starting from this point that I'm highlighting here, and it's ending at this point from the explanation we have there. So solving this directly, we can say the velocity of the particle, we can call that one Vx, will be equals to, it will be changing what displacement time graph, and this is dx by dt, which we have learned from integration. This is 4 2s are 8t's plus 2, and what we are looking for is for us to substitute t value to be 2, and when you do that, 8 2s are 16 plus 2 is going to give us 18 meters per second. Now the velocity in x direction. Then similarly, the y direction, we can also say the velocity in y direction, we call vy direction, will be equals to, differentiating these guys, we are going to have 5, and that is the answer for that. No need to substitute anything. That is 5 meters per second. Vy is also equals to, for those who want to write in full, this is the y by the t. So when you differentiate that, that is how we come about these two answers. Now, The question can actually ask you more, like asking you to calculate the magnitude and the direction of what? Of the 2D motion. So if you want to do that carefully, you just have to illustrate and understand that to get the magnitude of this, looking at the formula I've given to you for magnitude of what? Of motion, you can quickly come that what the magnitude of velocity is. The direct solution will now be magnitude of velocity can be written as, you can say magnitude of velocity we call V magnitude will now be equals to under root of Vx squared, the first one, that is 18 squares, plus Vy squared, which is 5 squares. So everybody should know that 18 squared is nothing but 376, I think I should be at 324, and 324 plus 5 squares are 25, so under root. So if you go by that, to get your magnitude of velocity will now be equals to square root. You can do that with calculator, it's going to be allowed. Now if you do that, this will give us 349, and square root of 349 will be the question answer to this. And if you punch your calculator, you are going to have the answer to be equals to 18.68 meters per second, which will be the direct solution to the question you are looking for. So now that I have introduced you to motion in one dimension, the next motion in two dimension, the next one we are going to discuss extensively on derivation of formula and other applications under motion in 2D. So guys, you can also try to calculate the direction, because what I've calculated here is